Welcome to our Azure Incident Retrospective. I'm David Steele.
I'm Sami Kuba. We work in the Azure Communications team.
In addition to providing a written post-incident review after major outages, we also now host these retrospective conversations.
You're about to watch a recording of a live stream where we invited impacted customers through Azure Service Health to join our panel of experts in a live Q&A.
We had a conversation about reliability as a shared responsibility. So this includes our learnings at Microsoft, as well as guidance for customers and partners to be more resilient.
We hope you enjoy the conversation that follows. Super, and today we're going to be focused on an incident. It was a utility power issue that had impact on our cooling units. This led to a shutdown of one of the 3 availability zones in our West Europe region, which led to impact to other multiple services across Azure. It occurred on the 5th, and it bled over to the 6th of November, but the incident lasted a total of about just under 9 hours.
That's right, long outage, but specifically kind of one of those zones within West Europe here. So to talk us through the incident, how we responded, and our learnings, I'd like to introduce a couple of engineering leaders joining as our guests today. First up, we have Nick Hengelman. Nick's our Senior Director from the Data Center Operations team that oversees a bunch of our data centers across several countries in the EMEA, kind of Europe, Middle East, Africa region. And we've also joined by David Barber. David is our Principal Product Manager from the Azure Storage team, and we'll talk a little bit about storage recovery as part of the incident today.
Super, but before we get to the incident, Nick, can I turn my attention to you? In my mind, we run hundreds of data centers around the world. Power disruptions seem to be relatively common. Cooling disruptions are less common, but could you talk to myself and our customers about what typically happens when there's a power disruption and how we kind of handle those things, and even a cooling disruption and how we handle those?
Yeah, thank you for that, Sami. So you're absolutely correct. Our data centers are built for redundancy. They're built to withstand what we call sag swell events on our grid. So an over or under voltage on our grid, and our data centers are equipped and redundant to serve under those circumstances. Our cooling systems are designed to commission to automatically restart after those power events, and they're built with sufficient redundancy as well to maintain safe operating conditions, even when failures occur.
So if we then cast our eyes on the 5th of November, that didn't happen in this case. And what was interesting about this? Why didn't the cooling automatically restart for this event? What made this special?
Yeah, so the incident that took place on the 5th, so it was triggered by a voltage sag, what we call a significant undervoltage on the grid. And it caused our cooling units to shut down and temperatures to rise above the normal thresholds that we would hold in our data center space. And that took place in a data center that's part of the Western Europe region. And it caused our cooling units to shut down and not automatically restart when the sag has passed.
Was it the characteristics of this sag? Like you mentioned that this was an unusual sag. Was it a case of we didn't design for, we didn't anticipate, or?
Yeah, that's correct. So in the design, we are designing for sag swell events. The scale and size of this sag event that took place on the grid caused an abnormal response from the as per design equipment, resulting into the shutdown of our cooling units when they hit the sag swell hit them.
Got it. That's helpful to understand. So there are sags and swells that we can handle, and this one wasn't like the others here. Nick, I'm interested to understand what customer pain felt like during this incident. I'd love to understand the blast radius a little more. In our introduction, we were talking about this bringing down one of the 3 zones within Western Europe, but based on your answer there, but this was just a part of one of those zones, right? This was specifically one data center, multiple data halls or colos, but one data center within one zone. Is that right?
Yeah, that's correct, David. And I think it's important to explain that as well, right? So the Western Europe region consists of the region in Amsterdam, and it does have the 3 zones, and this was impacting one of the zones. But to be very clear, this was one data center, multiple colos in this zone 1. I hope that answers your question.
Yeah, thank you for that. So I think, David, maybe this is a good time to bring you in here to talk a little bit about the storage perspective. So one data center has this cooling issue, and that means that IT hardware is kind of shutting down. It impacted multiple services, particularly because of a dependency on storage. Can you talk to us a little bit about what the storage impact here was?
Yeah, absolutely. So when you have an outage of this nature or the problem of this nature, one of the things that happens is you have sort of a broad impact across the data center or the colos, if you want to think about it that way. And when we have all these services that are sort of running on top of virtual machines, and then those virtual machines talk to storage on the back end. When you lose the storage, things get weird, for lack of a better term, right? They don't work the way that they should. And we have mechanisms built in that detect those issues and do things like pause the VM so that the VM stops and stops issuing reads and writes and I/O to the back end. But what we see when this happens is you basically see virtual machines stop functioning the way that you would expect. And of course, on top of that, that means applications stop functioning the way that you would expect, the way that our customers would expect. Now, the challenge here is that you've got a lot of them running and a lot of I/O going to storage, and you've got a lot of disks that are impacted at different times, because it's not like when the temperature starts to increase, it's not like you snap your fingers and all of a sudden everything shuts down and everything's coming back up at the same time and it's all consistent, right? What you have is you're reaching a temperature threshold over here and you're reaching temperature threshold over there. And I don't know if you want to get into the recovery yet. We'll talk about that in a few minutes, but basically you start to see services kind of pause because I/O is just going to stop to the back end disk at this point.
So I think you've prompted a question that I want to turn my attention to Nick for. Nick, as temperatures are rising, so we know that there's a sag, it knocked off our cooling units, temperatures are rising. As David mentioned, intermittent times, different storage scale units or nodes are shutting down. Could you walk us through the timeline of this? It was 9 hours. How did we detect? How did we investigate? How did we troubleshoot? How did we mitigate this kind of issue?
That's a great question, and I'll do my best to walk everybody through this in common sense, right? So we have our alert monitoring that will trigger an event like a sag or a swell, and from that moment we have set emergency operating procedures, or EOPs as I might refer to them, that come into play. Now these data centers, they're all fully staffed, right? So they have staff sitting around the clock, critical environment staff, making sure that those EOPs will be triggered with immediate effect. So the EOP was triggered. The team assessed the cooling situation that was on hand, because obviously with cooling units shutting down, the temperature of the actual storage piece is increasing, right? Our servers' temperatures are growing. The team assessed the first situation in the field. They looked at the cooling units. They noticed that they didn't auto start. So then they go following the procedure, and in that procedure, it's a manual restart. Unfortunately, they had to do that on quite a significant amount of cooling units, resulted into the cooling duration. I think the duration time to make all the manual restarts take place took 48 minutes or 50 minutes. Let's keep it to 50. And after that, we obviously saw an immediate recovery of the temperatures. And that duration of time to set everything back into manual restart, that is the time that's needed to actually bring the cooling back into the data center. And obviously then for David and the team to start the recovery process as well for the customers. We need the cooling to be there to even go out of auto shutdown of the servers.
Got it. That's a great rundown of kind of what's happening. Real people doing real things on site to bring those kind of cooling units back online. And David, that's kind of teed you up perfectly chronologically here. So then power is restored. This was only, an hour or two into this incident here. And we know it took a lot longer to kind of bring all the services back online. So talk us through the storage recovery here. What did that look like?
Yeah, so I think, one of the things that I want to talk about, I think, is that the question that we get is, why does it take so long? Right? Because we get the temperature under control relatively quickly compared to the entire timeline for the outage. Why does it take so long? So I want to start kind of explaining this with the principle here that data integrity is number one for us. That's what we are going to protect at all costs when it comes to storage. And because of that, let's just start where this temperature starts rising, right? So we can kind of paint a picture of what happens. So the cooling units go down, the temperature starts rising. Now we have components in the servers that are designed to protect the data, right? They're designed to make sure that every write that goes to the disk gets committed to the disk, okay? We have thresholds in place at certain temperatures to make sure that we don't damage those components. We don't want to melt them, right? We want to make sure that all the data gets to the disk, it's safe and sound, it's secure. And we have to do that across 3 replicas, okay? So keep that in mind. Now, what happens is when you have an event like this, you start, like I said earlier, the temperature doesn't just rise at the same time everywhere, right? And we don't shut down all these nodes or AKA services at the same time. So one hits the threshold and it shuts down, and another hits the threshold and it shuts down, and another hits the threshold and it shuts down. So, but imagine this at scale. So imagine this across multiple clusters of servers, if you will. And what that means is all of the I/O that's going to the servers that must be replicated stops happening at different times. Okay, and this is what leads to the really long recovery times, because you have all these slices of data distributed, you have them replicated so that we can maintain the integrity of the data, but you may have 3 copies that stopped writing at different times. Now, we have to fix that. We have to make sure that every bit is accounted for. And so that is part of what happens. So we bring everything up at the same time, but we have to validate the integrity of every slice of data for every single disk that was on that storage. And it takes a significant amount of time. Now, there's some things we can talk about in a few minutes. We talk about repair actions that we are looking at doing to reduce that recovery time. But essentially, even though we bring everything back up, we have to verify every slice of data. We have to make sure that every write is committed. We have to make sure that every copy is in sync. And then we can restore services. If we don't do that, really bad things happen, right? So databases are out of sync. There's all kinds of problems. And I'm just giving an example. But that is really what took the time. So when we get the engineers involved really early on in this incident. And then they kind of have to wait for the temperature to get back to an acceptable level. Then we have to start powering servers back on. They don't all come back on at the same time either, right? But we do bring up the storage tenants, the software, at the same time. Now we have to repair all the disks, all the slices of data, and that takes a significant amount of time. And I'll pause there and see if you have any questions, and if not, we can kind of go on and cover the repair actions, here in a few minutes.
That's great, David. Thank you for painting us that picture. And I think it's really important, as you did, that we kind of start from our principles around integrity and moving slowly and cautiously to make sure that all that data is accounted for and then consistent. That makes a lot of sense. But like you say, that's a good way to tee us up into some of our learnings and repairs here. But I'll bring Nick in first because I want to touch on these chronologically. When we're talking about some of our learnings and repairs, let's start from the data center perspective, since that was the trigger event here. Nick, I was reading the post-incident review, and we talked about a few different data center-related kind of learnings or improvements here. The first of which talked about these forensic investigations with our OEM vendors, and we talked about hardware there. That's not to do with IT hardware, that's to do with our cooling hardware, right? Do we have results of those investigations, or is that still ongoing?
Yeah, you're 100% correct. That is related to our cooling equipment, so what we would call our critical environment cooling capacity. So just to set the stage right, what typically happens when an incident took place, we go into root cause analysis modus, which is a process part of our incident management. We take these things very seriously. We have before the incident where we're really prepping and making sure that incidents cannot occur. Now we're in an incident, so we have during the incident, and I already walked you through the steps on how we then mitigate and how we recover. And then we have after the incident. And after the incident is actually the most important part. Because after the incident, we're really looking at what went wrong, what happened, what improvements do we need to drive to not have this happen again, because we have a wider fleet and we might have potential for reoccurrence somewhere else, right? That's obviously important for us, the top priority. So after the incident, we have the forensics team involved, which is our team that partners with the OEMs. So our Microsoft engineers will be involved, and we go to the location, and the OEM went to the location. They do their investigations. They actually, because we have redundancy, they actually also take parts to their laboratory to do investigations on. This is a power-driven event into our cooling, so it needs a deep dive. They do that, and then we also have our own forensics teams walk us through the steps. What happened? What's the timeline? What was the effect of what we caused in the data center, and how did that trickle down to the actual cooling shutting down? Now, if I take you to the current situation is we've done those assessments. We've identified issues with the circuit boards on the cooling units. And when I say we identified issues is we identified that the current as design, if it has challenges with withstanding a SAC swell of this scale and size. And we also found a solution for that. That solution, when we're talking about UPS backed up, is our data center, right? So it has a uninterrupted power supply backing up our power. You can also scale that down into the circuit boards of the cooling units. And you can say that we upgraded what we call ultra capacitors, which is a small UPS component. to be even more robust for a wider impact of SAC swells. And when we did that, we obviously do that in a controlled environment together with the OEM and our forensics team. We tested that. Test was very successful. We implemented the change, and that concludes it for this incident. Then we went obviously wider, and we assessed the whole fleet. Which of this equipment is affected? Is there any potential for other locations? And we did exactly the same retrofit in those locations as well. Now, in locations where this is still in motion, we're upgrading our staffing levels to make sure that there's extra mitigation, right? We don't want any residual risk in the fleet while this operation is in motion. But that's the latest status on those repair items, David.
So, and Sue and Nick, can I clarify, when you spoke about that, is that the gap analysis that you said that you were doing with the UPS and the power infrastructure? There was a line in the repair item that spoke about that gap analysis. Is that what the, super. So then my next question, can I ask, the other repair item that you mentioned was you're changing maintenance procedures and pre-checks, you're making these a little bit more rigorous. Can you talk to us a little bit more about what that entails?
Yeah, so when we do any kind of maintenance on our critical environment components, such as UPSs and cooling systems currently, a lot of it is testing and a lot of it is measuring. And we want to improve that by going above and beyond and not just testing, measuring, but also simulation. So there could be an element implemented in these procedures that we're now assessing if that's a usable component to add to the actual maintenance piece. And that is still in motion, and we hope to complete that actually this month.
That's great to hear that we're making progress on the data center side of things. Good to understand. David, I'd love to bring you back in here to talk a little bit about those kind of recovery steps that you mentioned. So, you know, we want to, once power is restored, we obviously want to bring things back online as quickly as possible. Can you be a little bit more specific here about how we're streamlining this kind of recovery at scale?
Yeah, of course. I think there's a couple of things that we are working on that will help in this case. So obviously this is an event that we hope never happens again. Right. But we also need to plan for the eventuality, and we want to cut the recovery time significantly. So there are two things that we think we can do. The first is controlling the shutdown so that things happen in a more orderly fashion. So I talked a little bit about how we have temperature rising, we hit a threshold sort of on a node by node thing, and these nodes go down in no particular order, right? Which means there's very little control over how much data is written to each one at any given time. In terms of like, it's very short amounts of time, but there's a lot of IO that can happen in a second or two, right? So one of the things that we're looking at doing is putting a threshold in where we see that once a percentage of nodes in a given cluster, aka tenant, aka scale unit, you'll hear those used sort of interchangeably. Once a certain percentage go down, we want to go ahead and stop services to the storage. And that is going to reduce the amount of time it takes to recover because we will have less slices and disks to repair on the back end, right? To make sure that the data integrity is maintained and that everything is where it's supposed to be when we bring services back up. So that's one thing that we are investigating doing. The other thing that we're doing, I mentioned a few minutes ago that we do recovery as what we call slices, right? So we have slices of data that's distributed across all of these disks, and we have to make sure that every replica of every slice is intact. That takes a lot of time. And the downside is it doesn't necessarily restore a disk from a customer perspective at the same time, right? So what we are looking at doing is saying, can we restore this at a VHD by VHD, so virtual hard drive by virtual hard disk? Can we do that restoration instead of slice by slice? And that way we can at least bring services up a little bit faster. It means the disk will come online rather than waiting for everything to come online. As the disks are restored, they come online and available to customers.
Super. And Dave, for our customers' context as well, we have LRS, we call it locally redundant storage, which means we store customer data in triplicate. We call them fault domains as well, to prevent, as you said, against data loss. So as you talk about the recovery, it is tricky to make sure all those things are in parity. David, if I can stay with you for a second. Sure. When I think about what customers could have done to become immune to this type of outage, because this was only in one availability zone, the first thing that springs to my mind is we have that covered. Customers using ZRS or zonally redundant storage. Would that have helped? Would GRS or ZRS been able to help in this type of situation?
Well, so ZRS is not currently offered on Premium SSD v2. So let's start there. Now, that doesn't mean customers can't protect themselves. It also doesn't mean there won't be challenges in a situation like this. What we recommend is that customers architect across availability zones. And we do have solutions for that. And most of our customers do. And so I want to say, like, I'm not coming here saying that, hey, we had a bunch of customers that weren't thinking about availability zones and high availability, right? They thought they did the right thing, and they did the right thing. And it can still be challenging when we recover. But first point, always architect across availability zones. Think about high availability. We don't need ZRS for high availability at the application layer, okay? The other thing is that I want to acknowledge a challenge that I know at least one customer had. It's knowing when our services are going to come back up, right? I don't think it's fair if we don't acknowledge that. So let's say customers are architected, but they don't know when to fail over. We can do a better job of letting customers know, hey, we think the services are going to come up at this time. Then customers can make that hard decision. Do I fail over from AZ1 to AZ2? Because in a lot of cases, these are not easy things to do, and they carry a certain level of risk for customers. That's just sort of the way it is in some of these cases, depending on the application. So the things that we're talking about doing from the repair perspective are going to help in those cases as well. Because if we can get the services up faster in a more predictable way, we can also inform customers what actions they need to take. And I think that's going to be super important.
That's a great summary there. So you're right, ZRS isn't the be-all and end-all. There are other ways of kind of thinking about, making sure storage is replicated across zones. And David, you've teed us up perfectly here when it comes to kind of keeping customers informed and trying to provide ETAs and more information about, how long this will take so that customers can make informed decisions. And that's why I've saved my last question for my co-host, Sammy, here. Sammy runs our Azure Incident Communications team. And so now that we've heard about our different learnings from the relevant teams, I want to bring communications in. Sammy, how did we do from a comms perspective? Did we keep customers up to date?
It's really interesting. So impact started around 16:53, but up until about an hour later, we didn't really know if there was customer impact. Azure has a huge amount of resiliency built in, and then there's lots of layers of redundancy. So it was only about kind of 17:40 that we understood there is customer impact, but we thought it was very scoped. And so we were working with our engineers to make sure that we communicate to those. Typically speaking, we like to communicate to impacted customers directly. We don't want to post things publicly. It can create red herrings. As David said, people might fail out or fail over, and it can be an expensive and introduce risk. So we like to generally target customers. 30 minutes or so after that, we saw that compute and PostgreSQL were also talking about impact. And the minute that signal came along and we realized impact was growing and we weren't able to communicate to impacted customers directly, and there were a bunch of customers who weren't being communicated to, and we were just kind of receiving those signals, we decided to go to our public status page. As David mentioned, we started offering ETAs when we had about 3 hours of recovery left. And it was great that we're able to say, dear Mr. and Mrs. Customers, it's going to take 3 hours. Customers could then make a decision whether to go home early, to fail out, to fail over, to call it a day. We did get it wrong. We were like a couple of hours out, but we tried to update customers as that was going on to say 3 hours. We had to revise it a couple of times, but that's kind of how we did this. The last piece here is that one of the experiments we're trying now in the communication space, that we know that time to notify is painful. A lot of times when customers see an issue, is it a me problem? Is it an Azure problem? And typically speaking, for the most part, we use Brain to communicate. And Brain didn't fire in this case, or it didn't fire broadly. It worked for a very small number of scenarios. But more importantly, I think what customers might start seeing is more communication around over-communication. Like, hey, we've got a signal, we're investigating, you haven't been confirmed as impacted. And so we're going to be more willing to pull that lever to over-communicate to customers and then hopefully dial it back in the moments that follow. So we don't know how customers are going to react. We don't want them to fail out or fail over just on the signal, but we want to give customers a heads up to say that we are investigating.
Yeah, that's interesting to touch on kind of a couple of those trade-offs that we often have internally. We have these debates internally about, can we give an ETA of when we think we'll be restored? And one of our big principles here is, hey, we can be wrong, but we can't say nothing. And so, and this is a great example of, hey, we think we're going to be restored in 3 hours. As that came closer and closer, turns out we've still got checks to run. We're still making sure that the data is in the right place. Here's a revised ETA. We still think that's better than not providing an ETA at all. So maybe this is a good kind of litmus test for that.
We can be wrong. We can't be opaque. That's it.
Thank you for watching this Azure Incident Retrospective. At the scale of which our cloud operates at, incidents are inevitable.
Just as Microsoft is always learning and improving, we hope our customers and partners can learn from these too, and provide a lot of reliability guidance through the Azure well-architected framework.
To ensure that you get posted incident reviews after an outage and invites to join these live stream Q&A sessions, please ensure that you have Azure Service Health Alerts set up. We really focused on being as transparent as possible and showing up and being accountable after these major incidents.
Whether it's an outage, a security, or a privacy event, Microsoft is investing heavily in these events to ensure that we earn, maintain, and at times rebuild your trust. Thanks for joining us.